friends, my name is Tushar and today I'm going to talk about how to find lowest common ancestor in a binary tree. Again, we are talking about a binary tree, not a binary search tree. So for example, this is the binary tree I have and I have two nodes. So for example 2 and 8, then what is the lowest common ancestor of 2 and 8? So 2 is here, 8 is here, so the lowest common ancestor of 2 and 8 is 3. So basically we're looking at a node from which the path diverge for the two nodes. Taking another example, lowest common ancestor of 2 and 5 is 6 because from 6 they diverge in two different directions. Similarly, lowest common ancestor of 9 and 5 is 11. Also lowest common ancestor of 8 and 7, so 8 and 7 is 8 because 8 is the ancestor of 7, so 8 also becomes the lowest common ancestor of 8 and 7. Similarly 9 and 3, the lowest common ancestor is 3. So how do we solve it? There are multiple ways to solve this. One solution is to traverse the path from root till the two nodes and see what are the common nodes between them. So for example, between 2 and 5, the path from root till 2 is 3, 6 and 2. And the path from root till 5 is 3, 6, 11 and 5. So what happens is we keep checking till the point at which this path gets different. So 3 and 3 is same, 6 and 6 is same, 2 and 11 is not same. It means that 6 is going to be the lowest common ancestor of 2 and 5 and 6 is the lowest common ancestor. The problem with this approach is that it needs extra space. So next we are going to look at the algorithm which does this, finds the lowest common ancestor in linear time and it does not take extra space. So the algorithm is as follows. You search for either of the two nodes whose lowest common ancestor we are looking for starting from the root node. Anytime any of the node is found, we return that node to its parent in the binary tree. Anytime any node gets a not null node from the left side and a not null node from the right side, it knows that it is the lowest common ancestor and then it returns its node value to its parent. Let me explain this with the help of example. So here we are looking for lowest common ancestor of 2 and 5. So 2 and 5. So starting from 3, we check if 3 is either 2 or 5. So node 3 is not same as node 2 or not same as node 5. So then we expand our search. We go on the left side. We check that is 6 same as 2 or 5. 6 is not same as 2 or 5, so we go on the left side again. So we check is 2 same as 2 or 5. So 2 is same as 2. So from this point we are going to return the node 2. Then from the 6 we are going to go and search on the right side. So again 11 is not same as 2 or 5. So then we expand our search area to 9. 9 is not same as 2 or 5. So now we have reached the null, we have reached the leaf node. So there is nothing more to look forward to. So this returns a null value to 11. Then 11 expands and looks on the right side. Is 5 same as either 2 or 5? So 5 is same as this. So this guy returns 5 to 11. What this means is that 11 cannot be the lowest common ancestor because it's getting a null from one side and a not null node from the other side. So 11 is ruled out. So what 11 does is just takes this not null node and returns it back to 6. So then 6 gets a not null node from the left side, a not null node from the right side, which means that 6 must be the lowest common ancestor of 2 and 5. So then 6 realizes that and it returns itself to its own parent, which is 3. So now 3 gets a 6 from the left side, and now it's going to do is expand the search on the right side. So 3 doesn't know that we have found the lowest common ancestor, so it will continue to search. So we go to 8, 8 is not same as 2 or 5. So we go to 13, 13 is not same as 2 or 5. And we go to 7, 7 is not same as 2 or 5. So 7 returns null, and then 13 returns null, and then 8 returns null. So at this point of time, 3 realizes that it got a not null node from the left side and it got a null node from the right side. So then it knows that the lowest common ancestor must be the node returned from this side, which is 6. So 6 is the returned node. We could have optimized things a little bit by checking that the return node from here is 6, and 6 is not same as 2 or 5, which means that 6 must be the lowest common ancestor. So we could have terminated our search and not go at all on the right side of 3. But for simplification purposes, I just explained the entire flow. Next, let's look at another example. Now we are looking to find the lowest common ancestor of 11 and 8. So again we start from 3. 3 is not same as 11 or 8, so we go on the left side. 6 is not same as 11 and 8, so we go on the left side. 2 is not same as 11 and 8. We have reached the leaf node, so we return null from here. Then 6 continues the search on the right side. This node is same as this 11, so we stop instantly here and return 11. So 6 got a null from left side and 11 from the right side. So 6 definitely is not a lowest common ancestor, so it's just going to propagate this 11 up to 3. So 3 gets an 11 from the left side. Then 3 doesn't know that we have found the lowest common ancestor or not, so 3 will continue looking on the right side. So then we go to 8 and we check if 8 is same as 8 or 11. So this 8 is same as this 8. So then this returns 8 value. So we stop immediately and return this node. So then 3 gets a not null from the left side, which is 11, and a not null from the right side, which is 8, which means that 3 must be the lowest common ancestor of 11 and 8. So 3 returns itself as the lowest common ancestor. So 3 is the lowest common ancestor in this example. Let's take one last example. Now we are looking for a lowest common ancestor of 8 and 7. 8 and 7. So we start from 3. 3 is not same as 8 and 7, so we go on the left side. 6 is not same as 8 and 7, so we go on the left side. 2 is not same as 8 and 7, 8 or 7, so this returns null. Then we go on the right side of 6. 11 is not same as 8 or 7. 9 is not same as 8 or 7, so 9 returns null. Then we go on the right side. 5 is not same as 8 or 7, so this returns null. So 11 is getting null from both the sides, so 11 is not going to be anyone's ancestor. So 11 returns null from itself. So 6 gets a null from the left side, 6 gets a null from the right side. So 6 is not an ancestor either, lowest common ancestor either, so it returns null. So now 3 will expand search on the right side. So we go here and 8 is same as this 8, so we instantly stop and return 8. So now 3 gets a null from the left side, a not null from the right side, so it propagates that not null value up. So basically meaning that 8 is the lowest common ancestor of 8 and 7. So as you can see how it works, even though 8 was the ancestor of 7, using this exact same algorithm, we figured out that this algorithm also works in the case where one node is an ancestor of another node. Next, let's look at the code for this algorithm. Code here is extremely simple. So the main function is LCA, lowest common ancestor. The node is root, which is the root of this binary tree, and node N1 and N2 are the two nodes whose lowest common ancestor we are looking for, and this returns that lowest common ancestor. So this is a recursive function. So if root is null, then we instantly return null. If root is same as N1 or root is same as N2, then we return this root. Otherwise, we go into the recursion on the left side of the root, passing same N1 and 2, and going into the recursion on the right side of the root, passing same N1 and 2, and then we get these two nodes left and right. And remember, this is happening recursively for every node. So we get these two nodes left and right this happens for every node. If left is not null and right is not null, what that means is I'm getting a not null node from the left side, I'm getting a not null node from the right side, which means that one of these two nodes were found on my left side and my right side, which means that this root is the lowest common ancestor, so we return root. Otherwise, if both left and right is null, so then we return null because neither of those two nodes were found on the left and right subtree of this root. And otherwise, if these two doesn't happen, then we just return the node which is not null among this left and right. So if left is not null, return left, otherwise return right. So as you can see, this code does exactly as what we discussed before with the help of example. So the runtime complexity for this algorithm is O of n. So this is all I have to talk about lowest common ancestor. Please like this video, share this video, comment on this video, check out my Facebook page and check out my GitHub link. The link to this code is in the description section of the video. Thanks again for watching this video.